Welcome, kind listener, to this peaceful haven of history. This is a place where stories flow like a gentle river, carrying us far away from the rush of the present. Whether you are lying in bed, eyes growing heavy, or sitting quietly as the evening settles, know that you are among friends here. If you'd like, share in the comments where you are listening from. I treasure the chance to see how history brings together people from every corner of the world. And if these calm journeys speak to you, go ahead and subscribe, so our paths may cross again in the chapters to come. But for now, let the noise of today drift away, and join me as we wander softly into the mists of the past. Tonight, we travel not to distant battlefields or ancient kingdoms, but to something more intimate, more quietly revolutionary. We journey into the mind of a man who changed the way we understand reality itself. This is the story of Albert Einstein, a tale that begins not with triumph but with silence, not with certainty but with questions that would reshape the very fabric of existence. Let his story unfold gently, like moonlight spreading across still water, and allow yourself to drift with it, wherever it may lead. In the late spring of 1879, in the German city of Ulm, a child came into the world who would one day peer into the heart of stars and unravel the mysteries of time. But on that March day, the 14th to be exact, there was no fanfare, no celestial sign marking his arrival. Hermann Einstein and his wife Pauline welcomed their son Albert into a world that seemed solid, predictable, governed by laws that Newton had carved into stone more than 2 centuries before. The universe, as everyone understood it, was a great clockwork mechanism, ticking away with perfect precision. Space was space, time was time, and never the two should meet. The city of Ulm sat nestled along the banks of the Danube, its medieval spires reaching toward the sky as they had for centuries. The cobblestone streets wound between buildings that remembered the Holy Roman Empire, and the air carried the scent of bread from bakeries that had been kneading dough since before anyone could remember. It was a place where tradition ran deep, where the old ways held fast against the creeping tide of modernity. And yet, change was coming. Railways were beginning to stitch together the German territories, telegraph wires hummed with invisible messages, and in workshops throughout Europe, inventors and engineers were dreaming of electric lights and horseless carriages. Hermann Einstein was one of these dreamers. He ran a small electrochemical business with his brother Jacob, crafting dynamos and electrical equipment in an age when such things still felt like magic to most people. He was a gentleman, optimistic by nature, always believing that the next invention, the next business venture, would bring prosperity. His wife Pauline brought music into their home, playing the piano with a grace that suggested refinement and culture. She was more practical than Hermann, more grounded, but she shared his appreciation for beauty and learning. Little Albert arrived with a head so large, so unusually shaped, that his grandmother took one look at him and reportedly exclaimed her worry aloud. His mother, too, felt a flutter of concern. But as days turned to weeks, the infant's appearance settled into something more ordinary, and the family's worries eased. What they couldn't know, of course, was what was forming inside that unusually shaped head, a mind that would one day comprehend the universe in ways no human being had ever managed before. The family did not stay long in Ulm. When Albert was just an infant, perhaps a year old, the Einsteins moved to Munich, where Hermann and Jacob hoped to expand their electrical business. Munich in the 1880s was a city transforming itself, shedding its medieval skin and reaching toward the industrial age. The air filled with the sounds of construction, the smell of coal smoke, the clatter of machinery. It was here, in this city of change and possibility, that young Albert would spend his childhood, and it was here that the first peculiarities of his character would begin to reveal themselves. He was slow to speak. While other children babbled and chattered, forming words and simple sentences, Albert remained largely silent. His parents worried. His grandmother worried. Was something wrong with the boy? But Albert was not broken or damaged. He was simply thinking, turning words over in his mind like stones in a river, examining them from every angle before releasing them into the world. When he finally did speak, he would often do so in complete sentences, having rehearsed them silently, perfecting them in the privacy of his thoughts. Throughout his life, this would remain his way, to think deeply, slowly, turning problems over and over until understanding emerged like a photograph developing in a dark room. There is a story, perhaps embellished but containing a kernel of truth, about young Albert receiving a compass from his father when he was 4 or 5 years old. The boy was ill, confined to bed, and Hermann brought him the compass to lift his spirits. Albert held the brass instrument in his small hands and watched the needle swing and settle, always pointing north, always knowing which way to turn no matter how he rotated the case. Something invisible was moving that needle. Something he could not see or touch was reaching through the brass and glass, through his hands, through the very air, compelling the needle to point in a specific direction. The universe, he realized with the stunned wonder that only a child can feel, was full of hidden forces, secret mechanisms operating beneath the surface of ordinary things. This moment, if we can trust the memory, planted a seed that would grow throughout his life, a conviction that reality was stranger and more wonderful than it appeared, that patient observation and careful thought could reveal truths invisible to the casual glance. School came, as it does for all children, and Albert entered the Peterschule, a Catholic elementary school despite his family's Jewish heritage. The Einsteins were not religious. They observed no dietary laws, attended no synagogue, and felt themselves more German than anything else. But in the late 19th century, in Germany as elsewhere, heritage clung to you whether you claimed it or not. At the Peterschule, Albert was the only Jewish child in his class, a fact that occasionally manifested in small cruelties from other children. But for the most part, his early schooling passed without particular trauma or particular distinction. The German education system of the time was rigid, authoritarian, built on memorization and obedience rather than curiosity and exploration. Teachers expected students to sit still, to listen, to repeat back what they were told without question. Military discipline had seeped into the classroom, and the ideal student was one who could march in time, intellectually speaking, with all the others. Albert Einstein, with his dreamy nature and his habit of questioning everything, was not the ideal student. He learned what interested him and ignored the rest. He would later describe his teachers as sergeants, and the school itself as a kind of barracks where young minds were drilled into conformity. But at home, something different was happening. Uncle Jacob, the engineer and mathematician who ran the electrical business with Hermann, took an interest in young Albert's education. He introduced the boy to algebra, presenting mathematical problems as puzzles to be solved rather than tedious exercises to be endured. Albert discovered that mathematics possessed its own kind of beauty, its own internal logic that felt more certain, more trustworthy than the arbitrary rules that governed so much of human life. Where language was slippery and social conventions baffling, mathematics was clear and pure. An equation, once proven true, remained true forever, unchanging and reliable as the stars. Jacob would pose problems to Albert, and the boy would work on them for days or weeks, refusing to give up, refusing to accept defeat. When he finally arrived at a solution, he felt a rush of joy that no other accomplishment could match. This pattern, too, would define his life, the willingness to sit with a problem for years if necessary, turning it over and over in his mind, approaching it from every conceivable angle until the answer revealed itself. He learned early that intelligence was not about speed or quick recall. It was about persistence, imagination, and the courage to think differently than everyone else. Another formative influence entered Albert's life in the form of Max Talmud, a young medical student who came to dinner with the Einstein family every Thursday evening. This was a tradition among German Jewish families, inviting a struggling student to share a weekly meal, a small act of charity and community. Max brought books with him, ideas, a window into worlds beyond Munich. He introduced Albert to popular science books, to philosophy, to the idea that knowledge was not just something you acquired in school but something you could pursue on your own, following your curiosity wherever it led. Together they read Aaron Bernstein's popular books on natural science, which described scientific concepts in language that a child could understand. They discussed light, time, space, the nature of matter, and with each conversation, Albert felt his understanding of the universe expanding like a balloon filling with air. Max also introduced Albert to Kant's Critique of Pure Reason, a work far beyond what any teenager should be able to comprehend, but Albert devoured it anyway. He may not have understood everything, but he grasped the central question that Kant was wrestling with: how do we know what we know? What can we trust about our perceptions of reality? These were not idle philosophical musings for Albert. They were urgent, vital questions that went to the heart of existence itself. If our senses could deceive us, if our basic assumptions about space and time might be wrong, then what could we rely on? Only mathematics, only the internal logic of a well-constructed theory, only the patient work of reasoning from first principles to their inevitable conclusions. Music, too, played its part in shaping the young man Albert was becoming. His mother insisted that he learn the violin, and at first, he resented it, enduring lessons because he had no choice. But then, around the age of 13, he discovered Mozart, and something shifted. Mozart's music possessed a kind of mathematical elegance, a crystalline purity that spoke to the same part of Albert's mind that loved geometry and algebra. He began to practice not because he was told to, but because he wanted to, because playing the violin brought him a sense of peace and order that the chaotic world could not disturb. Throughout his life, when he was stuck on a problem, unable to see his way forward, he would take up his violin and play. The music seemed to untangle his thoughts, to clear a path through the confusion. He would play, and then suddenly, the answer would be there, waiting for him. At the Luitpold Gymnasium, the school Albert attended after completing his elementary education, the authoritarian atmosphere that had bothered him before became unbearable. The teachers were strict, demanding, intolerant of any deviation from their prescribed methods. They wanted students to memorize and regurgitate, to accept what they were told without question. Albert wanted to understand, to explore, to challenge assumptions. This made him unpopular with his instructors, who saw him as insolent, disrespectful, a negative influence on the other students. One teacher, it is said, told him outright that he would never amount to anything, that his very presence undermined classroom discipline. Such words might have crushed another child, but Albert seemed almost indifferent to them. He knew his own mind. He trusted his own understanding. What did it matter what some frustrated teacher thought of him? His real education was happening outside the classroom anyway. He was teaching himself calculus, working through textbooks on his own, racing ahead of what the school curriculum demanded. By the time he was 15, he had mastered mathematics that most students wouldn't encounter until university. He read widely in physics and philosophy, always searching for the fundamental principles, the deepest truths. He was not content with surfaces or appearances. He wanted to know how things really worked, what laws governed the universe at its most basic level. But then the Einstein family's fortunes took a turn. The electrical business that Hermann and Jacob had worked so hard to build was failing. They could not compete with the larger companies that had better financing, more advanced technology, better connections. In 1894, the family made the difficult decision to leave Munich and move to Italy, where they hoped to start fresh, to find new opportunities. Hermann, Pauline, and Albert's younger sister Maya would go to Pavia, near Milan, and begin again. But what about Albert? He was still enrolled at the gymnasium, still working toward the diploma he would need for university. The family decided he should stay behind in Munich, boarding with a distant relative, finishing his studies. For a teenage boy already feeling isolated and constrained, this separation was unbearable. He was alone in Munich, in a school he despised, far from his family. The building where he lodged was cold and unwelcoming. The winter pressed down on the city, and everything felt gray and heavy. His teachers continued to criticize him, to see him as a problem rather than a pupil. And so Albert did something that would have been unthinkable for most young people of his time and place. He dropped out. He obtained a note from a doctor certifying that he was suffering from nervous exhaustion and needed rest, and then he gathered his few belongings and set out for Italy, for his family, for freedom. The months Albert spent in Italy were perhaps the happiest of his young life. The warmth, the light, the relaxed atmosphere of Italian society. All of it was so different from the rigid, militaristic culture of Germany. He wandered through the countryside, visited art galleries, sat in cafes and watched people live with a joy and spontaneity that seemed impossible in Munich. He helped his father and uncle with their new business ventures, doing calculations, solving technical problems, making himself useful. But he was also unmoored, adrift. He had no diploma, no clear path forward, and as the months passed, the question of his future grew more pressing. What was he going to do with his life? The answer, everyone agreed, should be higher education. But without a gymnasium diploma, Albert could not enter a German university. However, there was another option, the Swiss Federal Polytechnic in Zurich, known by its German acronym as the ETH. This institution had a more flexible admissions policy. If a student could pass the entrance examination, they could be admitted regardless of whether they had a traditional diploma. Albert, confident in his mathematical abilities, decided to take the exam. He was only 16, 2 years younger than most applicants, but he believed he could pass. He was wrong, or at least partly wrong. When the results came back, they showed a young man of extraordinary ability in mathematics and physics, but with significant gaps in other subjects, languages, biology, literature. The director of the school, a man named Albin Herzog, recognized Albert's exceptional talent in the sciences and suggested a path forward. Albert should spend a year at a Swiss secondary school in Aarau, filling in the gaps in his education, and then he could enter the Polytechnic without having to retake the entrance exam. And so Albert found himself in Aarau, a small Swiss town where the pace of life was gentle and the school atmosphere unlike anything he had experienced before. The cantonal school there was progressive by the standards of the time, emphasizing understanding over memorization, encouraging students to think independently, to question, to explore. Albert thrived. He boarded with one of the teachers, Jost Winteller, whose family welcomed him warmly, treating him like a son. He developed a teenage romance with Winteller's daughter Marie, experiencing for the first time the giddy, confusing, wonderful feelings that come with young love. He hiked in the mountains, played music, studied with a freedom and enthusiasm that had been impossible in Munich. He also began thinking seriously about light, about how it traveled through space, about what it would be like to ride alongside a beam of light, matching its speed, seeing the universe from that impossible perspective. These were the kinds of thought experiments that would later revolutionize physics, but for now they were just the idle musings of a curious teenager lying on his back in the Swiss grass, watching clouds drift across the summer sky. In 1896, at the age of 17, Albert took another significant step. He renounced his German citizenship. He wanted no further connection to the militaristic, authoritarian state he had fled. For the next 5 years, he would be stateless, a person without a country, until he could afford to apply for Swiss citizenship. This liminal status suited him. He had never felt particularly bound by borders or national identities anyway. He thought of himself as a citizen of the world, or perhaps more accurately, as a citizen of the universe of ideas, a realm that transcended all merely human boundaries. That same year, he successfully completed his studies at Aarau and entered the Polytechnic in Zurich, enrolling in the program to become a teacher of mathematics and physics. Zurich in the late 1890s was a vibrant, cosmopolitan city, a center of science and culture where new ideas circulated freely and old hierarchies mattered less than talent and ambition. The Polytechnic itself was one of Europe's leading technical schools, with excellent laboratories and a faculty that included some of the continent's finest minds. Albert should have been ecstatic. He had achieved what he set out to do. He was studying physics and mathematics at a prestigious institution. The future stretched before him, full of possibility. But Albert was not an easy student, not even here. He had strong opinions about what was worth studying and what was not. He often skipped lectures that didn't interest him, preferring to study on his own, reading papers by the physicists whose work truly excited him: Maxwell, Helmholtz, Hertz, Kirchhoff. He was searching for something his professors were not teaching, a deeper understanding of the fundamental nature of reality. The required curriculum seemed to him outdated, too focused on classical mechanics and not sufficiently engaged with the newest developments in electromagnetic theory and statistical mechanics. He would borrow notebooks from friends to catch up on what he had missed in lectures, then spend his time in the library or his room, teaching himself what he really wanted to know. This approach did not endear him to his professors. Hermann Minkowski, who taught mathematics at the Polytechnic, would later recall Einstein as a lazy dog who rarely attended class. This assessment was both unfair and revealing. Albert was not lazy. He was ferociously dedicated to learning, but only on his own terms, following his own path. The structure of formal education, with its requirements and deadlines and prescribed syllabi, felt like a constraint rather than an aid. He wanted to think freely, to explore wherever his curiosity led, and the institution kept trying to channel him in directions that felt arbitrary and pointless. During these years at the Polytechnic, Albert met Miliva Maric, the only woman in his section, a Serbian physics student with her own brilliant mind and her own struggles against the prejudices of the time. She was 3 years older than Albert, serious and intense, with dark eyes and a slight limp from a childhood illness. They recognized something in each other, a shared passion for physics, a shared sense of being outsiders in a world that didn't quite know what to do with them. They began studying together, discussing ideas, pushing each other to think more deeply. A friendship developed, and then something more than friendship, a romance that would shape both their lives in profound and ultimately painful ways. Albert graduated from the Polytechnic in 1900, but just barely. His grades were adequate but not exceptional, and his relationships with his professors ranged from cool to hostile. When it came time to find positions for the graduating students, the professors arranged assistantships for everyone in Albert's cohort except for him. This was a devastating blow. In the academic world of the time, an assistantship was the first step toward a career in research and teaching. Without one, the path forward was far from clear. Albert sent out application after application to universities across Europe, hoping for any position that would allow him to continue his work in physics. Every application was rejected. He was unemployed, living on borrowed money, watching his classmates move forward while he remained stuck. The reasons for this rejection were complex. Partly, it was his own fault. His reputation for skipping classes and challenging his professors had followed him. Partly, it was bad luck and bad timing. But partly, too, it was the quiet anti-Semitism that permeated European academia, the unspoken understanding that certain positions were not for Jewish scholars, no matter how talented. Albert was German by culture, Swiss by choice, but Jewish by blood, and in some circles, that was enough to close doors that should have opened. He took temporary teaching positions, filling in at schools here and there, never staying long, never finding stability. He tutored students. He grew increasingly desperate. Miliva, meanwhile, had become pregnant. She returned to Serbia to give birth in secrecy to a daughter they named Lizarl. What happened to Lieserl remains one of the mysteries of Einstein's life. She disappears from the historical record, never mentioned in his later correspondence, her fate uncertain. Perhaps she died in infancy. Perhaps she was given up for adoption. Perhaps Maleeva's family raised her in Serbia, far from Albert and the life he was building. We do not know, and that unknowing haunts the story, a shadow at the beginning of his adult life. Finally, in 1902, through the help of a friend, Marcel Grossman, Albert secured a position at the Swiss Patent Office in Bern. It was not the academic position he had hoped for. It was not research or teaching. It was a bureaucratic job, evaluating patent applications for new inventions, making sure they were novel and workable. For someone with Albert's education and ambitions, it must have felt like failure, like settling for something far beneath his abilities. But in retrospect, we can see that this job was perhaps the best thing that could have happened to him. It was not mentally taxing. He could complete his work efficiently, leaving mental energy for his own thinking. The patent applications themselves were fascinating, little windows into how inventors were grappling with the technologies of the age, electrical devices, mechanical innovations, all the machinery that was reshaping modern life. And crucially, he had time. Time to think. Time to read. Time to pursue the questions that truly mattered to him. In January of 1903, Albert and Maleeva married in a small ceremony in Bern. There was no family present, just a few friends to witness the union. Albert's parents disapproved of the match, particularly his mother, who felt Maleeva was too old, too serious, not good enough for her son. But Albert went ahead anyway, asserting his independence, choosing his own path as he always had. The early years of their marriage were, by all accounts, happy enough. They lived modestly in Bern, two physicists setting up house together, discussing ideas over meals, taking walks along the river. In 1904, their first son, Hans Albert, was born, and for a while, domestic life and intellectual life coexisted in precarious balance. But Albert's mind was elsewhere, or perhaps it would be more accurate to say that his mind was everywhere, ranging across the fundamental questions of physics with an intensity and focus that was almost frightening. He had identified what he called the lucky strike, the key problems that, if solved, would unlock new levels of understanding. And in 1905, in an explosion of creativity that has no real parallel in the history of science, he solved not one but several of these problems, producing in a single year a series of papers that would reshape physics forever. This year, 1905, would come to be called Albert Einstein's Annus Mirabilis, his miracle year. He was 26 years old, working full-time at the patent office, raising a young son, and in his spare time, revolutionizing our understanding of the universe. In March, he submitted a paper on the photoelectric effect, proposing that light, which everyone understood as a wave, could also behave as particles, discrete packets of energy that he called light quanta. This idea was so radical, so contrary to everything physicists believed about the nature of light, that even Max Planck, who had introduced the concept of quantized energy a few years earlier, thought Einstein was going too far. And yet, this paper would eventually earn Einstein the Nobel Prize and help lay the foundation for quantum mechanics, the strange and counterintuitive theory that governs the behavior of matter and energy at the smallest scales. In May, he submitted a paper on Brownian motion, the jittery movement of tiny particles suspended in fluid. Botanist Robert Brown had first observed this phenomenon decades earlier, watching pollen grains dance and tremble under his microscope, but no one had been able to explain it. Einstein showed that the motion was caused by molecules of the fluid colliding with the particles, providing powerful evidence that atoms and molecules, though too small to see, were real physical objects and not just useful fictions for organizing data. This paper helped convince the last holdouts in the scientific community that matter was indeed made of atoms, settling a debate that had raged for decades. But it was the papers he submitted in June and September that would truly change everything. These papers dealt with what Einstein called the principle of relativity, and they introduced to the world what we now call the special theory of relativity. The core insight was simple to state but staggering in its implications. Einstein proposed that the laws of physics should be the same for all observers, no matter how they're moving relative to each other. This might not sound revolutionary, but it led Einstein to an astonishing conclusion: the speed of light must be constant, the same for every observer, regardless of how fast they are moving. This meant that space and time, which everyone assumed were fixed and absolute, were actually flexible, changeable, dependent on the observer's motion. Time could pass at different rates for different observers. Distances could shrink or expand depending on your frame of reference. Space and time were not the rigid stage on which events played out. They were part of the play itself, bending and warping in ways that seemed to violate common sense but were nonetheless true. These papers were published in Annalen der Physik, one of the leading physics journals of the day, but at first, they caused barely a ripple. Einstein was an unknown patent clerk. He had no academic position, no powerful mentors promoting his work. The papers themselves were written in a clear, almost conversational style, without the elaborate mathematical apparatus that might have signaled their importance to other physicists. A few people noticed. Max Planck, in Berlin, read the papers and recognized their significance. He began corresponding with Einstein, asking questions, thinking through the implications. Others, too, started to pay attention, but it would be years before the full impact of Einstein's ideas began to be felt throughout the physics community. In those papers, buried in the mathematical arguments, was one equation that would become the most famous in all of science: E equals mc squared. Energy equals mass times the speed of light squared. This simple equation revealed that mass and energy were not separate things but different forms of the same fundamental stuff. A tiny amount of mass could be converted into an enormous amount of energy because the speed of light squared is such a huge number. The implications were staggering, though no one, not even Einstein, fully understood them at the time. This equation would eventually explain how the sun shines, how stars burn for billions of years, and, tragically, how nuclear weapons could release destruction on a scale previously unimaginable. But in 1905, Einstein was still a patent clerk in Bern. His miracle year had happened in obscurity, his genius unrecognized by the wider world. He submitted one of his papers as a doctoral dissertation to the University of Zurich, hoping to finally earn his PhD and perhaps improve his prospects for an academic position. The dissertation was initially rejected as too short. He added one sentence and resubmitted it, and this time it was accepted. Dr. Einstein, at last. But the title meant little without a position where he could use it. Slowly, gradually, recognition came. Physicists began to understand that something important had happened, that this unknown man had seen things others had missed. In 1908, Einstein was offered a position as a lecturer at the University of Bern. It was a junior position, poorly paid, teaching early morning classes to a handful of students, but it was a foothold in academia. He kept his job at the patent office, working both positions, exhausting himself but finally moving in the direction he had always wanted to go. The following year brought a better offer. The University of Zurich created a position for him as an associate professor of theoretical physics. Now he could leave the patent office, could devote himself fully to physics and teaching. He was 30 years old. It had taken a long time, far longer than it should have, but he was finally where he belonged. But Einstein was not finished. The special theory of relativity applied only to observers moving at constant speeds relative to each other. What about acceleration? What about gravity? These questions gnawed at him. In 1907, he had what he would later call the happiest thought of his life. He imagined a man falling from a roof. During the fall, the man would feel weightless. He would not feel his own weight, because he and everything around him were falling at the same rate. This simple thought experiment revealed something profound. Acceleration and gravity were intimately connected, perhaps even equivalent. An accelerating observer experiences effects identical to those experienced by an observer in a gravitational field. This insight, which Einstein called the equivalence principle, would guide him toward his greatest achievement, the general theory of relativity, but that journey would take nearly another decade of intense, difficult, often frustrating work. In Zurich, Einstein threw himself into teaching and research. He was not a polished lecturer. His classes were informal, conversational, sometimes disorganized. But students loved him because he was genuine, because he struggled openly with difficult concepts, because he treated them as colleagues rather than subordinates. He would invite students to cafes after class, continuing discussions over coffee, always willing to engage, to explore ideas together. His reputation grew, and with it came more offers. In 1911, he accepted a full professorship at the German University in Prague. It was a prestigious position, but Prague felt foreign to him. The city was beautiful but divided, caught in ethnic tensions between Czechs and Germans. Einstein felt isolated there, cut off from the vibrant scientific community he had enjoyed in Zurich. He continued his work on relativity, but the going was hard. The mathematics required to describe gravity's effects on space and time were far more complex than anything he had tackled before. He needed tools from branches of mathematics he barely knew, geometries that could describe curved spaces, tensors, and differential equations that made his head spin. After just a year and a half in Prague, Einstein returned to Zurich, this time to his alma mater, the Polytechnic, which had finally recognized his worth and offered him a professorship. He was coming home, and it felt right. But even this position would not hold him long. The centers of physics research were in Germany, particularly in Berlin, and in 1913, Einstein received an offer he could not refuse. The Prussian Academy of Sciences invited him to become a member, with no teaching duties, a generous salary, and complete freedom to pursue his research. Max Planck and Walther Nernst traveled to Zurich to present the offer in person, showing just how highly the German scientific establishment now valued this man they had once ignored. Einstein accepted, and in 1914, he moved to Berlin. It was a fateful decision, one that would place him at the center of European science during one of history's most tumultuous periods. He arrived in Berlin just months before the world exploded into war. In August of 1914, the Great War began, and Europe tore itself apart. Nations that had seemed civilized revealed themselves capable of industrial-scale slaughter. New technologies, machine guns, poison gas, tanks, aircraft, turned battlefields into charnel houses. Millions died, and the old order, the certainty that progress and reason would inevitably triumph, died with them. Einstein was horrified by the war and by the nationalism that fueled it. While most German intellectuals, including many of his colleagues, signed manifestos supporting Germany's cause, justifying its actions, Einstein refused. He signed a counter-manifesto calling for peace, for European unity, for an end to the madness. This took courage. In wartime Berlin, dissent was dangerous, and Einstein's pacifist stance made him enemies. But he would not be silent. He could not cheer for destruction, could not pretend that slaughtering young men in trenches served any noble purpose. His personal life was collapsing as well. The marriage to Mileva had been deteriorating for years. The intellectual partnership that had once connected them had faded. They quarreled constantly. Mileva was unhappy in Berlin, isolated, struggling with depression. Albert, consumed by his work on general relativity, had little energy left for domestic concerns. In 1914, Mileva took their two sons and returned to Zurich. The marriage was over in all but name, though the formal divorce would not come for several years. Albert threw himself even deeper into his work, as if the mathematics of curved spacetime could provide the order and beauty that the rest of his life lacked. And then, in November of 1915, after years of struggle, after false starts and dead ends and moments of despair, Einstein finally arrived at the correct equations for general relativity. He submitted a series of papers to the Prussian Academy, laying out his theory in full. Space and time were not just flexible, as special relativity had shown. They were curved by the presence of mass and energy. Massive objects like stars and planets bent the fabric of spacetime around them, and this curvature was what we experience as gravity. Objects moved not because some invisible force pulled on them, but because they were following the natural curves in spacetime, like marbles rolling along the contours of a stretched rubber sheet. It was beautiful, elegant, profound. The equations unified space, time, matter, and gravity into a single coherent framework. They explained Mercury's odd orbit, which had puzzled astronomers for decades. They predicted that light should bend when passing near massive objects, that time should run slower in strong gravitational fields, that the universe itself might be expanding or contracting rather than remaining static. Einstein had achieved what he set out to do. He had found a deeper level of reality, had seen past the surfaces to the underlying structure. He was 36 years old. But would anyone believe him? The theory was strange, counterintuitive, and made predictions that seemed impossible to test. How do you measure the curvature of spacetime? How do you prove that massive objects bend light? The answer came in 1919, when British astronomer Arthur Eddington led expeditions to observe a total solar eclipse. During the eclipse, stars near the sun became visible, and Eddington measured their positions. If Einstein was right, the sun's gravity should bend the light from those stars, making them appear slightly displaced from their usual positions. The measurements were difficult, the data imperfect, but when Eddington announced his results, they confirmed Einstein's prediction. Light did bend. Spacetime did curve. Einstein was right. The announcement made headlines around the world. Here was something good, something hopeful, emerging from the wreckage of the war. A German scientist's theory confirmed by British scientists, cooperation triumphing over nationalism, human understanding advancing despite all the destruction. Einstein became an international celebrity overnight. Newspapers described him as the man who had overthrown Newton, who had revealed a new universe more strange and wonderful than anyone had imagined. His photograph appeared everywhere, that distinctive wild hair, the sad eyes, the slightly disheveled appearance. He looked like everyone's idea of a genius, and the public embraced him with an enthusiasm that sometimes baffled and disturbed him. Fame changed Einstein's life in ways he had not anticipated. He received invitations to lecture around the world. Reporters sought interviews. People stopped him on the street. He tried to use this fame for causes he believed in, advocating for peace, for international cooperation, for Zionism and the creation of a Jewish homeland, though he had complicated feelings about nationalism of any kind. He traveled to America, to Japan, to Palestine, speaking to enormous crowds, meeting with world leaders. Everywhere he went, people wanted to touch him, to hear him speak, to be in the presence of genius. But some in Germany resented his fame, particularly those on the nationalist right who saw him as an internationalist, a pacifist, and above all, a Jew. Anti-Semitism was rising in Germany, fueled by resentment over the war's outcome, by economic crisis, by the need to find scapegoats for national humiliation. Einstein received death threats. One organization called the Study Group of German Natural Philosophers held a public event at the Berlin Philharmonic Hall in 1920, dedicated to denouncing Einstein's theories as fraudulent Jewish physics. The speakers were not serious scientists but cranks and ideologues, yet the event was well attended, and newspapers covered it sympathetically. Einstein attended incognito, sitting in the audience and listening to himself being denounced. He responded with humor and grace, but privately he worried about what these attacks revealed about Germany's direction. He continued his scientific work, but the years after 1915 were less revolutionary than the miracle year or the decade spent developing general relativity. He worked on unified field theory, trying to find a single framework that would unite gravity and electromagnetism, but this project would occupy him for the rest of his life without success. He contributed to the development of quantum mechanics, that strange new physics that described the behavior of atoms and subatomic particles, but he grew increasingly uncomfortable with the direction this field was taking. Quantum mechanics, as it developed through the 1920s, revealed a universe far stranger than even relativity had suggested. At the quantum level, particles did not have definite positions or velocities until they were measured. They existed in states of probability, of potentiality, occupying multiple states simultaneously until observation collapsed them into a single outcome. The act of measurement changed what was being measured. Particles could be connected across vast distances in ways that seemed to defy the limits of space and time. Cause and effect grew blurry. Certainty dissolved into probability. Einstein hated this. He had spent his life searching for order, for clear laws that governed the universe with precision and elegance. The quantum world, with its randomness and uncertainty, felt wrong to him. He engaged in a long-running debate with Niels Bohr, one of the architects of quantum theory, arguing that the theory must be incomplete, that there must be hidden variables underneath the probabilities, some deeper level of reality that would restore determinism and order. He famously declared that God does not play dice with the universe. Bohr, more comfortable with uncertainty, replied that Einstein should stop telling God what to do. This debate was not just about physics. It was about the nature of reality itself, about whether the universe was fundamentally knowable or whether some essential mystery would always remain. Einstein, despite revolutionizing physics twice and overturning long-held certainties, was at heart a classical physicist, believing in an objective reality that existed independent of observation. Quantum mechanics suggested something different, something that made reality itself dependent on measurement, on the interaction between observer and observed. Einstein could not accept this, and his resistance to quantum theory would marginalize him somewhat in the physics community during his later years, even as his earlier achievements continued to be celebrated. His personal life, meanwhile, found a new equilibrium. In 1919, he finally divorced Mileva, a process that was bitter and painful. As part of the settlement, he promised her the money from his Nobel Prize, which he had not yet received but which everyone assumed was inevitable. In 1921, the prize finally came, awarded for his work on the photoelectric effect rather than for relativity, which was still considered too controversial. True to his word, Einstein sent the prize money to Mileva. He had already remarried by then, wedding his cousin Elsa Einstein in 1919. Elsa was practical, protective, skilled at managing the demands that fame placed on her husband. She shielded him from intrusions, organized his household, allowed him the peace and routine he needed for his work. It was not a grand romance. Theirs was a partnership of convenience and companionship, and it seemed to suit them both well enough. Einstein remained devoted to his sons from his first marriage, though his relationship with them was complicated by distance and by the wounds the divorce had inflicted. Hans Albert, the older son, would grow up to become an engineer, making his own distinguished career. Edouard, the younger, was brilliant and sensitive, but he would eventually succumb to schizophrenia, spending much of his adult life institutionalized. This was a source of great sadness for Einstein, a reminder that genius and madness could live close together, that the human mind was fragile in ways that all his understanding of the cosmos could not protect against. Through the 1920s, Einstein's fame only grew. He became a symbol not just of scientific achievement but of human potential itself, proof that one person's insights could reshape our understanding of existence. He received honorary degrees from universities around the world. He met with presidents and prime ministers. He used his platform to advocate for causes he believed in, speaking out against militarism, supporting civil rights, promoting scientific education. He was particularly passionate about pacifism, believing that another war would be catastrophic and that nations needed to find ways to resolve conflicts without resorting to violence. But events were moving in directions he could not control. The German economy collapsed in the early 1920s, hyperinflation destroying savings and livelihoods. Political violence became common. The fragile democracy of the Weimar Republic struggled against extremists from both left and right. And on the right, a small party led by an Austrian veteran named Adolf Hitler was growing, feeding on resentment and offering simple answers to complex problems. The Nazi Party blamed Germany's troubles on communists, on foreign powers, on Jews. They promised to restore German greatness, to purify the nation, to create a new order. In 1933, they came to power. Einstein was out of the country when Hitler became chancellor. He had been visiting the United States, lecturing and conducting research. He announced that he would not return to Germany. The Nazis had already made clear their hatred of him. His name appeared on lists of enemies of the state. His property was confiscated. Books by Jewish authors were being burned. Jewish professors were being dismissed from universities. The new regime was erasing Jewish contributions to German culture, science, and intellectual life, as if centuries of achievement could be undone by decree. The world Einstein had known was ending. The Germany that had produced Goethe and Beethoven, Kant and Gauss, the Germany of science and philosophy and culture, was transforming into something monstrous. Other Jewish intellectuals were fleeing too, those who could, streaming out of Germany and Austria as the shadow deepened. Many did not leave in time. Many believed it would pass, that Germany would come to its senses, that the madness was temporary. They were wrong. Einstein settled in the United States, accepting a position at the Institute for Advanced Study in Princeton, New Jersey. This new institute was designed to be a haven for pure research, a place where brilliant minds could work without the burdens of teaching or administration, supported by generous funding and surrounded by colleagues equally dedicated to expanding human knowledge. It seemed an ideal position for Einstein's later years, a quiet place where he could continue his quest for a unified theory, where he could think and work in peace. Princeton was a gentle town, leafy and calm, far from the tumult of Europe. Einstein bought a modest house on Mercer Street and settled into a routine. He walked to the institute each day, his uncombed hair and rumpled sweater becoming a familiar sight in the neighborhood. Children would see him on the street and wave. He would help them with their homework sometimes, explaining mathematical concepts with the same patience he had once shown students in Zurich. He seemed, on the surface, like any eccentric professor, absent-minded and harmless. But he could not escape what was happening in Europe. News came in letters, in newspaper reports, in the arrival of refugees carrying stories of horror. The Nazis were not just persecuting Jews but systematically destroying them, creating laws that stripped away rights, organizing violence, herding people into ghettos, and eventually, though the full scale of it would not be clear until later, into concentration camps and extermination centers. The Holocaust, that industrial-scale genocide, was unfolding, and among its 6 million Jewish victims were Einstein's relatives, colleagues, friends, people whose only crime was being born into a heritage that a regime had decided to eradicate. Einstein agonized over his pacifism. He had always believed that violence solved nothing, that wars were crimes against humanity. But what do you do when faced with absolute evil? Could pacifism be maintained in the face of Hitler? In the late 1930s, with war looming, Einstein reluctantly concluded that Nazi Germany had to be stopped, even if that meant war. This was a painful reversal for him, an acknowledgement that sometimes violence, terrible as it is, might be necessary to prevent something worse. In 1939, events took a turn that would haunt Einstein for the rest of his life. Physicists discovered that uranium atoms could be split in a process called fission, releasing enormous amounts of energy. Scientists quickly realized that this process could be weaponized, that a chain reaction of splitting atoms could produce an explosion of unprecedented power. German scientists were aware of this. The possibility that Nazi Germany might develop an atomic bomb was terrifying. A group of refugee physicists, led by Leo Szilard, convinced Einstein to lend his name and prestige to a letter addressed to President Franklin Roosevelt, warning him of this danger and urging the United States to begin its own atomic research. Einstein signed the letter, though he did not write it and was not deeply involved in the technical details. The letter, dated August 2, 1939, helped convince Roosevelt to initiate what would become the Manhattan Project, the massive secret program that developed the first atomic bombs. Einstein himself was not involved in the Manhattan Project. His pacifist politics made him a security risk in the eyes of military authorities. He spent the war years in Princeton, working on his unified field theory, consulting occasionally on conventional weapons projects for the Navy, but kept far from the nuclear research that his famous equation, E=mc², had helped make possible. He did not know about the bombs being built until, like everyone else, he heard about Hiroshima. On August 6, 1945, an American bomber dropped an atomic bomb on the Japanese city of Hiroshima. The explosion killed perhaps 70,000 people instantly, with tens of thousands more dying later from radiation and injuries. 3 days later, another bomb destroyed Nagasaki. Japan surrendered, and the war ended. The world had entered the atomic age, and the potential for human destruction had increased by orders of magnitude. Einstein was horrified. He felt responsible, though rationally he knew his contribution had been minimal and indirect. His theories had revealed the equivalence of mass and energy. His letter had helped initiate the American program. But he had not built the bombs, had not chosen to use them, had not even known they existed until they fell. Still, the association between Einstein and the atomic bomb would persist, another burden added to his fame. He was the genius whose insights had unlocked both the energy of stars and the power to destroy cities. In the remaining years of his life, Einstein became an advocate for nuclear disarmament and world government. He argued that in an age of atomic weapons, war between major powers had become suicidal, that humanity needed to find new ways of resolving conflicts or face extinction. He joined with other scientists to form organizations promoting arms control and international cooperation. He spoke publicly about the danger, using his celebrity to draw attention to issues he considered existential. But his scientific work continued to frustrate him. The unified field theory remained elusive. He filled notebooks with calculations, trying approach after approach, but nothing worked. Younger physicists were pursuing quantum field theory and particle physics, exploring the subatomic realm with new accelerators and detectors. Einstein's approach seemed old-fashioned to many of them, his rejection of quantum mechanics a failure to adapt. He had become, in some ways, a relic, honored for his past achievements but no longer at the forefront of physics. This isolation did not seem to bother him much. He had never needed approval or sought to be fashionable. He followed his own path, as he always had, working on the problems that mattered to him regardless of whether others thought them promising. He played his violin. He sailed, though he often let the boat drift, more interested in thought than navigation. He corresponded with scientists, philosophers, and ordinary people who wrote to him with questions. He received thousands of letters and tried to answer many of them, offering encouragement to students, comfort to the grieving, his thoughts on everything from physics to politics to the existence of God. His views on religion were complex and often misunderstood. He did not believe in a personal God, in a deity who answered prayers or concerned himself with human affairs. But he felt a deep sense of wonder at the universe, a feeling he described as religious, a humility before the mystery and beauty of existence. He spoke of Spinoza's God, a God identical with nature itself, with the rational order underlying reality. He believed that the pursuit of science was itself a spiritual activity, an attempt to understand the mind of God by studying the creation. This was not conventional religion, but it was not simple materialism either. Einstein inhabited a space between belief and skepticism, awed by the universe but unwilling to accept doctrines that contradicted reason and evidence. In his 70s, Einstein's health began to decline. He suffered from an aortic aneurysm, a weakening in the wall of his body's largest artery. Doctors told him it could rupture at any time, killing him quickly. He accepted this with the same calm he had brought to most of life's challenges. He continued working, knowing that death was close but not particularly afraid. In April of 1955, the aneurysm ruptured. He was taken to Princeton Hospital, where doctors urged him to consider surgery. Einstein refused. He had lived his life, done his work. He was 76 years old and ready for the end. In the early morning hours of April 18, 1955, Albert Einstein died. A night nurse heard him murmur something in German, but she did not understand the language, and so his last words, whatever they were lost. He had requested no funeral, no grave marker, no place of pilgrimage. His body was cremated and his ashes scattered in a location that remained secret. He wanted to disappear, to leave behind only his work, not monuments or relics. But of course, his work remains, and its impact continues to grow. The special and general theories of relativity are foundational to modern physics. Every GPS satellite orbiting Earth must account for relativistic time dilation, or its signals would be hopelessly inaccurate. Our understanding of the universe, its origin in the Big Bang, the existence of black holes, the expansion of space itself, rests on Einstein's insights. Astronomers have detected gravitational waves, ripples in spacetime predicted by general relativity and observed for the first time a century after Einstein published his theory. Every confirmation is another validation of his vision. The quantum mechanics he resisted has proven equally foundational, governing the behavior of semiconductors in our computers, the lasers in our optical drives, the MRI machines that peer inside our bodies. His skepticism about quantum theory was wrong in the end, but even his wrongness was productive, forcing physicists to think more carefully about the theory's implications, to design experiments that tested its predictions. His debates with Bohr clarified the issues and pushed the field forward. And beyond the technical achievements, Einstein remains a symbol. He represents the power of human thought, the possibility that one person, thinking deeply and carefully, can change how we understand reality. He showed that genius does not require conformity, that the greatest insights often come from those willing to question everything, even the most basic assumptions about how the world works. His life demonstrates that brilliance can coexist with kindness, that you can revolutionize physics and still play with neighborhood children, still respond to strangers' letters, still stand up for justice and peace even when doing so costs you. There is a photograph taken in his later years that captures something essential about Einstein. He is sitting in his study in Princeton, surrounded by papers and books, his hair completely white now, his face deeply lined. He is looking at the camera with those sad, wise eyes, and there is in his expression something both weary and hopeful. He has seen so much: 2 world wars, the Holocaust, the atomic bomb, the destruction of the Europe he once knew. He has achieved more than most humans could dream of achieving, unlocked secrets of the universe that had been hidden since the beginning of time. But he has also failed, has not found his unified theory, has not prevented the catastrophes he warned against. The expression on his face seems to acknowledge all of this, the triumph and the tragedy, the wonder and the horror, holding them together in a mind that could encompass contradictions. What drove him? What made Einstein Einstein? Part of it was surely innate, an unusual brain, a particular configuration of neurons that processed information in extraordinary ways. After his death, the pathologist who performed the autopsy removed Einstein's brain without permission, hoping to discover what made it special. Studies over the years have found some unusual features: a larger than average parietal lobe, differences in the corpus callosum, an unusually complex pattern of folds and fissures. But whether these features explain his genius or are merely correlative remains uncertain. Brains are not simple machines where you can point to a structure and say, "There, that is where relativity came from." Beyond neurology, there was his character, forged in those early years of struggle. His willingness to think independently, to trust his own judgment over authority, to follow logic wherever it led regardless of how strange the conclusions seemed. His patience, learned through years of working on problems that resisted solution. His playfulness, his ability to approach physics with the freedom and imagination of a child. His thought experiments, imagining riding alongside a light beam, imagining falling from a roof, imagining clocks and trains and observers in motion. These were not just pedagogical devices but essential tools of discovery, ways of seeing past the mathematics to the physical reality underneath. There was also timing. Einstein came of age at precisely the moment when physics was ready for revolution. The classical physics of Newton had been pushed to its limits. Experiments were revealing phenomena: the constant speed of light, the photoelectric effect, the spectrum of blackbody radiation, the strange behavior of Mercury's orbit, that could not be explained by existing theories. The pieces were lying on the table. Someone needed to see how they fit together. Einstein saw. Others might have eventually, but he saw first, and he saw more clearly than anyone else could. And finally, perhaps there was necessity. Einstein needed to understand the universe the way other people need food or air. It was not a hobby or a career but a fundamental drive, a compulsion that shaped every aspect of his life. He sacrificed conventional success, family harmony, financial security, national belonging, all in service of this need. Some of those sacrifices hurt others, particularly the women and children in his life who often came second to his work. We should not ignore this. Genius does not excuse neglect. But it helps explain the single-minded focus that made his achievements possible. Late at night, in his study in Princeton, Einstein would sometimes sit alone with his calculations, filling page after page with equations, searching for the pattern that would unite gravity and electromagnetism, the theory that would complete his life's work. He never found it. The unified field theory remained out of reach, a dream unfulfilled. But perhaps that is fitting. Einstein's life was not about completion or perfection. It was about the search itself, the endless curiosity, the refusal to accept that any question was unanswerable. He showed us not just new answers but new ways of asking questions, new possibilities for understanding. The boy who once lay in bed staring at a compass, wondering about invisible forces, grew into the men who revealed that space and time themselves were forces, were fluid and dynamic, were stranger than anyone had imagined. The student who struggled in school, who was told he would never amount to anything, became the scientist whose name is synonymous with genius. The patent clerk working in obscurity in Bern transformed into the most famous scientist in the world. The refugee fleeing Nazi Germany became a symbol of science's international character, its transcendence of political boundaries. His influence extended far beyond physics. Artists and writers drew inspiration from relativity, from its suggestion that reality was subjective, dependent on perspective. Philosophers grappled with its implications for our understanding of space, time, and causality. The general public, too, was affected, even if most people never understood the mathematics. The idea that one person's brilliant thinking could overturn centuries of certainty, could reveal a universe stranger and more wonderful than we knew, captured imaginations everywhere. Einstein made science exciting, made it feel like an adventure, a journey into unknown territories where anything might be discovered. There is a danger in focusing too much on individual genius, in telling the story of science as if it were just a sequence of brilliant individuals having insights. Science is a collective enterprise, built on the work of thousands of people, most of whose names are forgotten. Einstein himself relied on the experimental work of others, on the mathematical tools developed by previous generations, on the community of physicists who tested his theories and extended his ideas. He was one node in a vast network of human inquiry stretching back to the first person who wondered why the stars moved the way they did. But even acknowledging this, Einstein's contributions were extraordinary. Some nodes in the network matter more than others. Some individuals push the entire enterprise forward in ways that change the trajectory of discovery. Einstein was one of these rare figures, and his absence would have left a hole that might have taken decades to fill. Special relativity might have eventually emerged from the work of Lorentz and Poincaré. General relativity is harder to imagine without Einstein. Who else would have had the vision to see gravity as curved spacetime? Who else would have had the courage to propose something so radical, so contrary to common sense? As you lie there now, listener, perhaps drifting towards sleep, imagine Einstein in his various phases. The slow-speaking child examining his compass with wonder. The rebellious teenager hiking through the Italian countryside. The young patent clerk in Bern, analyzing applications by day and revolutionizing physics at night. The professor in Zurich, discussing ideas with students over coffee. The celebrity in Berlin, famous but increasingly alarmed by the political darkness gathering around him. The refugee in Princeton, gray-haired and weary, still searching for answers, still playing his violin, still marveling at the mystery of existence. All of these Einsteins were the same person, and yet each was different, shaped by time and experience, by triumph and loss. The through line connecting them all was curiosity, that insatiable need to understand. From childhood to death, through changing countries and careers, through fame and obscurity, through war and peace, Einstein never stopped asking why, never stopped searching for deeper truth, never stopped believing that the universe could be understood if you thought about it carefully enough. There is something comforting in this, is there not? In an uncertain world, where so much feels arbitrary and chaotic, Einstein's life suggests that reason matters, that thinking carefully about problems can lead to real understanding, that the universe, for all its strangeness, follows rules that human minds can comprehend. We may never understand it completely. There may always be mysteries beyond our reach. But we can understand more tomorrow than we do today, and more the day after that. The frontier of knowledge can expand indefinitely if we keep pushing, keep questioning, keep thinking. Einstein's scientific work revealed that the universe is more unified than it appears. Space and time are aspects of a single spacetime. Mass and energy are different forms of the same thing. Gravity and acceleration are equivalent. Beneath the surface diversity, there are deep connections, fundamental patterns. His life, too, reveals connections. The physics and the philosophy, the science and the music, the personal and the political, all flowed from the same source, the same questing intelligence trying to make sense of existence. He was not perfect. He was often a difficult person, stubborn, self-absorbed, more comfortable with ideas than emotions. His first marriage failed largely because he could not meet Maleva's needs, could not be the partner she deserved. His relationship with his sons was complicated and sometimes distant. He could be neglectful of the people who loved him, present in body but absent in spirit, his mind always elsewhere, always chasing some problem. These failings are part of the story too. Heroes in reality are always more complicated than heroes in myth. But his virtues were real as well. He stood up for what he believed in even when it cost him. He opposed war when most intellectuals were supporting it. He spoke out against racism in America, joining civil rights causes, refusing invitations to institutions that discriminated against Black Americans. He advocated for refugees and used his fame to help scientists fleeing persecution. He maintained friendships across national and political lines, believing that science transcended such divisions. He was generous with his time and attention, responding to letters from strangers, helping young scientists, explaining his ideas to anyone genuinely curious. And he remained, always, capable of wonder. Late in life, someone asked him what question he would most like to answer. Einstein replied that he would like to know whether God had any choice in creating the universe, whether the laws of physics were the only logically consistent set, or whether other universes with different laws were possible. This question, which we would now frame in terms of string theory and the multiverse, reveals Einstein's deepest concern. He wanted to know if the universe was necessary, if it had to be the way it is, or if it was contingent, arbitrary, one possibility among many. He never got his answer. We still do not have it. But the fact that he could frame the question, that he could think on such a scale, shows the scope of his imagination. Imagine him on one of his sailing trips, letting the boat drift on a New Jersey lake, lying back and looking at the sky. The same stars that ancient humans watched, that Ptolemy and Copernicus and Galileo studied, that Newton explained with his laws of motion and gravitation. But Einstein had seen past those laws to something deeper. He knew that the starlight had traveled through curved spacetime to reach his eyes, that the very fabric of reality was warped by massive objects, that those stars were fusing hydrogen into helium in their cores, converting mass into energy according to his equation, burning with fires that would last billions of years. He knew all this, and yet he could still simply lie there and watch them twinkle, could still feel the same awe that any human has felt looking at the night sky. This combination of deep knowledge and deep humility, of understanding and wonder, was perhaps Einstein's greatest gift. He showed us that learning more about the universe does not diminish its mystery but deepens it. Every answer reveals new questions. Every horizon reached shows new horizons beyond. The more we understand, the more we realize how much we do not understand. This is not frustrating but exhilarating. It means there is always more to discover, always deeper to go, always new frontiers for human thought. In his later years, Einstein received a letter from a young girl who asked if scientists pray, and if so, what they pray for. Einstein replied that a scientist will hardly be inclined to believe that events are influenced by a prayer, by a wish supernaturally transmitted. However, he continued, everyone who is seriously involved in the pursuit of science becomes convinced that some spirit is manifest in the laws of the universe, one that is vastly superior to that of man. In this way, the pursuit of science leads to a religious feeling of a special sort, quite different from the religiosity of someone more naive. This religious feeling, this sense of standing before something vast and mysterious and beautiful, infused all of Einstein's work. He approached physics not as a technician solving puzzles but as a seeker searching for truth, for the deep structure underlying reality. His equations were not just calculations but revelations, glimpses of the divine, if we understand divine not as supernatural but as the ultimate nature of what is. He wanted to read God's thoughts, he said. Everything else was details. Did he succeed? Partly. He saw further than anyone before him. He revealed patterns in nature that had been invisible. He gave us new eyes to see the universe. But the ultimate theory, the final answer, eluded him. Perhaps it always will. Perhaps there is no final answer, only an infinite series of deeper and deeper understandings, each opening onto new mysteries. If so, that seems fitting. It means the adventure never ends. It means every generation of scientists can make discoveries that matter, can push human knowledge forward, can experience the joy that Einstein felt when a calculation finally worked, when the pieces finally fit together, when understanding suddenly blazed through confusion like light through clouds. His legacy is not just his theories but his example. He showed that you do not have to be conventional to make contributions that matter. He showed that imagination is as important as knowledge, that playfulness and serious thought can coexist, that physics is not just about equations but about visualizing reality, telling stories about how the world works, building mental models that capture something true. He showed that science is not separate from ethics or politics or art but connected to them, part of the larger human project of trying to live well and understand our place in the cosmos. As we approach the end of our journey through Einstein's life, notice how it feels to have spent this time with him, to have walked through his years, witnessed his struggles and triumphs, understood something of what drove him and what he achieved. History, when told well, does this. It brings us close to people who lived long ago or far away, helps us see the world through their eyes, reminds us that every life contains depths we cannot fully fathom. Einstein has been dead for nearly 70 years, but through the stories we tell and the work he left behind, he remains present, still teaching, still inspiring, still asking us to think more deeply about the nature of reality. What would he think of physics today? The discoveries that have come after his death would surely delight him. The confirmation of gravitational waves, detected by instruments so sensitive they can measure distortions in spacetime smaller than the width of a proton. The discovery that the universe is not just expanding but accelerating, driven by some mysterious dark energy that Einstein himself briefly postulated and then abandoned. The observation of black holes, those ultimate manifestations of curved spacetime where gravity becomes so strong that not even light can escape. The detection of the Higgs boson, the particle that gives other particles their mass. The growing understanding of the quantum world through experiments that probe the boundaries between the possible and the impossible. But he would also find much to puzzle over. The fact that dark matter and dark energy, which together constitute 95% of the universe, remain mysterious. The fact that quantum mechanics and general relativity still resist unification, that we still do not have a quantum theory of gravity that works at all scales. The fact that string theory, the leading candidate for such a theory, predicts extra dimensions and multiple universes but has yet to make testable predictions. He would be encouraged that physicists are still searching for the unified theory he sought, but he might worry that they have not made as much progress as he hoped. And what would he think of the world? The bombs he helped unleash have not been used in war since Nagasaki, but they remain, thousands of them, still threatening. The world government he advocated has not come to pass, though international institutions try to manage conflicts and coordinate responses to global challenges. Science has advanced beyond anything he could have imagined: computers, the internet, genetic engineering, artificial intelligence. Would these developments please him or alarm him? Both, probably. He always had a complex relationship with technology, recognizing its power to help or harm depending on how it was used. But these speculations are ultimately futile. Einstein is gone. We have only what he left behind: his papers, his letters, his theories, the memories of those who knew him, and the impact of his work on everything that came after. We have the example of his life, a reminder that individual human beings can matter, can make a difference, can change the trajectory of history through the power of thought. As the night deepens and sleep approaches, let Einstein's story settle over you like a blanket. Let it remind you that curiosity is one of our finest qualities, that asking questions matters, that trying to understand the world is a worthy way to spend a life. You do not have to be Einstein to make contributions. You do not have to revolutionize physics to matter. Every person who looks at the world with wonder, who asks why things are the way they are, who pursues understanding with honesty and persistence, is participating in the same great human project that Einstein devoted himself to. There is a photograph, taken near the end of Einstein's life, that shows him laughing. His whole face is crinkled with mirth, his eyes bright, his mouth open in what looks like genuine delight. Whatever joke or comment prompted this expression is lost, but the image captures something essential about who he was underneath the genius and the fame. He was a human being who could laugh, who could find joy, who could, despite everything he had seen and experienced, maintain his sense of humor and his basic optimism about human nature. This seems like a good image to carry with us as we finish our time together tonight. Not Einstein the marble statue, the secular saint of science, but Einstein the person, complicated and flawed and brilliant and kind, who lived and struggled and wondered and discovered and finally, when his time came, let go and departed, leaving behind a universe transformed by his understanding of it. The stars that Einstein studied are still there, burning in the darkness. The laws he uncovered still govern their behavior. Space and time still curve around massive objects. Light still bends. Clocks still run at different rates depending on motion and gravity. Energy and mass are still equivalent. The universe is still stranger and more beautiful than common sense suggests. All of this remains true, independent of whether anyone notices or understands. But we do notice. We do understand, at least partially. Because Einstein lived. Because he thought deeply about these things. Because he had the courage to propose ideas that seemed crazy. Because he trusted mathematics and logic more than intuition. Because he persisted when others would have given up. Because he devoted his life to understanding. And now you know his story, or at least some version of it, told in a way meant to carry you gently through this night. You have traveled from Ulm to Princeton, from childhood to old age, from obscurity to fame, from classical physics to relativity. You have seen a life unfold, with all its complications and achievements, its joys and sorrows, its moments of triumph and stretches of frustration. What do you take from it? Perhaps simply this, that it is worth trying to understand. That the universe rewards patient attention. That thinking carefully about difficult problems can lead to insights that change everything. That imagination matters as much as knowledge. That curiosity is its own justification. That one life, lived with purpose and dedication, can ripple outward across generations, touching millions of people who will never know your name but will benefit from your work. Einstein's equations describe the universe, but his life describes something too, a certain kind of human excellence, a way of being in the world that combines intellectual rigor with moral courage, scientific precision with humanistic concern, revolutionary insight with personal humility. We might not be able to match his scientific achievements, but we can aspire to live with the same commitment to truth, the same refusal to accept easy answers, the same willingness to follow our questions wherever they lead. As your eyes grow heavy and consciousness begins to fade, let the last images be these: Einstein as a small boy, watching a compass needle point steadily north, beginning to wonder about invisible forces. Einstein as a young man in Bern, working in the patent office and revolutionizing physics in his spare time. Einstein in his prime, presenting his theory of general relativity, revealing that gravity is the curvature of spacetime itself. Einstein in old age, still searching, still wondering, still playing his violin, still marveling at the mystery of existence. And perhaps, as you drift into sleep, you will dream of curved spacetime and bending light, of clocks that run at different speeds and distances that shrink and expand. Perhaps you will dream of riding alongside a light beam, as Einstein once imagined, traveling at the speed of light through a universe that reveals its secrets slowly, reluctantly, only to those patient and clever enough to ask the right questions. Or perhaps you will simply sleep peacefully, knowing that the universe is stranger and more wonderful than it seems, that human minds can comprehend it despite its strangeness, and that somewhere in the long history of human thought, a man named Albert Einstein spent his life trying to understand it all, and succeeded better than almost anyone before or since. Rest now, kind listener. The story is finished. Einstein's journey from that day in Ulm to that night in Princeton is complete. What he discovered remains, written in mathematics, encoded in technology, woven into our understanding of reality itself. Space and time are not what they seem. Energy and mass are two faces of the same coin. The universe is not a static stage but a dynamic, evolving entity where matter curves spacetime and spacetime tells matter how to move. These truths, strange as they are now part of humanity's inheritance, passed down from Einstein to every generation that follows. We live in the universe he helped us see, navigate it with technologies his insights made possible, understand it through frameworks he constructed. His gift to us was not just knowledge but a way of knowing, a demonstration that reality yields to patient inquiry, that the universe makes sense even when that sense contradicts our intuitions. As sleep takes hold, let yourself feel the weight of time, the way Einstein taught us to understand it. Time is not a river flowing uniformly for everyone. It is personal, local, dependent on motion and gravity. The clock beside your bed ticks at a different rate than a clock on a mountaintop or aboard a satellite. The difference is tiny, imperceptible without precise instruments, but it is real. Time itself bends and flexes like everything else in this malleable universe. And space, too, the very distance between objects, is not fixed. It expands between galaxies, carrying them apart from each other faster and faster. The universe is bigger now than it was when you began reading this story, and it will be bigger still tomorrow. Einstein's equations predicted this expansion decades before astronomers observed it, another triumph of pure thought revealing truths about reality that observation would later confirm. Imagine the young Einstein, barely out of his teens, already sensing that something was wrong with the accepted understanding of light and motion. Imagine the years of thinking, the thought experiments, the false starts and revisions. Imagine finally arriving at the insight that the speed of light must be constant for all observers, and then following that insight to its logical conclusion, space and time must be relative. The courage this required cannot be overstated. He was proposing that humanity's most basic intuitions about the nature of reality were wrong, that we had misunderstood space and time throughout our entire history. And he was right. Experiments confirmed it. The universe really works the way Einstein said it does. This is perhaps the most remarkable aspect of his achievement, not just that he had revolutionary ideas, but that his revolutionary ideas were correct. Many people have proposed radical new ways of understanding reality. Most of them were wrong. Einstein was right, again and again, across multiple domains of physics. His intuition about the deep structure of nature was astonishingly accurate. What was the source of this intuition? How did he know what questions to ask, what principles to trust, what paths would lead to truth? He spoke of a kind of feeling, an aesthetic sense that guided him. Beautiful theories were more likely to be true than ugly ones. Elegant mathematics reflected elegant physics. Simplicity and symmetry were signs that you were on the right track. These were not rigorous criteria, not formal methods, but they worked for him. They allowed him to navigate through the infinite space of possible theories toward the few that actually described reality. Other physicists had some of the pieces. Lorentz had developed mathematical transformations that described how measurements change between moving reference frames. Poincaré had discussed the relativity of simultaneity. But neither of them made the conceptual leap that Einstein made, neither of them saw that space and time themselves were relative, that the transformations were not just mathematical tricks but reflections of physical reality. Einstein saw this, and seeing it changed everything. It is late now, deep into the night, and the world around you is quiet. In this quietness, it is easy to imagine other nights, other moments of stillness when important thoughts took shape. Einstein lying awake in Bern, puzzling over the photoelectric effect. Einstein walking through the streets of Prague, trying to understand gravity. Einstein at his desk in Berlin, working through the mathematics of curved spacetime, page after page of calculations, some leading nowhere, others bringing him closer to the truth he sought. These moments of solitary thought, these hours spent wrestling with abstract concepts, produced insights that transformed civilization. The technology you use today, computers, GPS, telecommunications, all rest on foundations Einstein helped build. The quantum physics he contributed to, even while doubting its ultimate validity, enabled the transistors and semiconductors that power modern electronics. The nuclear physics that emerged from his mass-energy equation drives the sun and could, if we learn to harness fusion, provide clean energy for millennia. But beyond the practical applications, beyond the technology and the engineering, there is something else Einstein gave us, a sense of the profound strangeness of existence. We live in a universe far weirder than our ancestors imagined. Space and time are not absolute. Matter and energy are interchangeable. The very fabric of reality bends and ripples. Massive objects distort space around them like weights on a rubber sheet. Light follows the curves in this space, traveling paths that are straight in curved geometry but look bent to our eyes. Black holes exist, regions where spacetime curves so extremely that not even light can escape. At their centers, the equations break down, predicting infinite densities and infinite curvatures, suggesting that something in our understanding is still incomplete. Einstein himself struggled with black holes, finding them disturbing even though they were solutions to his own equations. He hoped they might not exist in nature. But they do exist. We have observed them, detected their gravitational waves, even photographed the shadow one casts against the light behind it. The universe, Einstein showed us, is far more interesting than we thought. It had a beginning, the Big Bang, emerging from an infinitely dense, infinitely hot point about 13.8 billion years ago. Before that moment, if before even makes sense, there was no space, no time, no matter, no energy. Nothing. And then, suddenly, everything. The universe began expanding and cooling, and as it did, particles formed, then atoms, then stars and galaxies, eventually planets and life and consciousness and us, lying here now, thinking about how it all began. Einstein's equations describe this history, predict how the universe evolves over time. Modern cosmology is built on general relativity. When astronomers measure the rate of expansion, when they calculate the age of the universe, when they model its future evolution, they are using mathematics Einstein developed over a century ago. His work endures because it captures something true, something fundamental about the nature of reality. And yet, for all his achievements, Einstein remained humble about how much he did not know. He recognized that his theories, successful as they were probably not the final word. General relativity breaks down at the quantum scale. Quantum mechanics, for all its predictive power, lacks a satisfying interpretation. The unified theory Einstein sought remains undiscovered. These gaps in our understanding do not diminish what Einstein accomplished. They simply mark the boundaries of human knowledge, the frontiers where the next generation of physicists will make their contributions. Perhaps you, listener, will be one of them. Perhaps something in Einstein's story has sparked a curiosity that will lead you to study physics, to pursue your own questions about the nature of reality. Or perhaps you will apply the lessons of his life to some other domain, approaching problems with patience and imagination, trusting your own judgment even when it contradicts conventional wisdom, searching always for deeper understanding beneath surface appearances. Or perhaps you will simply carry forward a sense of wonder about the universe, an appreciation for how strange and beautiful it is, how much there is to discover, how rewarding it can be to really think about things carefully and honestly. This, too, is valuable. A society that values curiosity, that supports scientific inquiry, that celebrates intellectual achievement, is a society that will continue to advance, to solve problems, to build a better future. Einstein understood this. He knew that science was not just a professional activity for specialists but part of human culture, something that should be accessible and meaningful to everyone. He gave public lectures, wrote popular articles, tried to explain his ideas in language non-specialists could understand. He believed that science belonged to everyone, that the insights it produced were too important to remain locked away in academic journals. The universe is everyone's home. Understanding it is everyone's birthright. In the darkness of your room, think about what the universe is made of. Atoms, yes, protons and neutrons and electrons, quarks and leptons, all the particles catalogued by the standard model of particle physics. But also energy, fields permeating space, virtual particles popping in and out of existence, quantum fluctuations that prevent true emptiness. And underlying it all, space-time itself, that four-dimensional fabric that matter curves and energy warps, the stage that is also part of the performance. This is the world Einstein revealed, and it is the world we inhabit. Every moment you exist, you are moving through space-time, following a path called a world line, tracing your personal trajectory through the four dimensions of reality. You are made of particles that were forged in stars billions of years ago, scattered through space when those stars exploded, eventually gathering into the planet beneath you and the body that is you. You are quite literally stardust, cosmic matter become conscious, the universe examining itself. Einstein knew this, felt it deeply. He understood that we are not separate from the universe but part of it, subject to the same laws that govern galaxies and atoms. This knowledge could be humbling or empowering, depending on how you hold it. Einstein chose empowerment. If we are part of the universe, then by understanding ourselves we understand the universe, and by understanding the universe we understand ourselves. Consciousness and cosmos are connected, woven together in ways we are still working out. Some nights, Einstein would look up at the stars and feel the vastness, the terrible and wonderful scale of it all. Billions of stars in our galaxy, billions of galaxies in the observable universe, each one following the paths that gravity dictates, moving through curved spacetime in an immense cosmic dance that has been going on for billions of years and will continue for billions more. And somewhere in all that vastness, on a small planet orbiting an ordinary star in an unremarkable galaxy, a curious primate had figured out some of the rules, had decoded some of the universe's secrets, had reached beyond immediate survival to ask why and how and what it all means. This is what Einstein's life represents, the triumph of curiosity over indifference, understanding over ignorance, reason over superstition. It represents the human spirit at its best, reaching for truths beyond immediate utility, valuing knowledge for its own sake, refusing to accept that any question is unaskable or any problem unsolvable. His life says to us across the decades, think, wonder, question, calculate, imagine, persist. The answers are there, waiting to be found. As your breathing slows and deepens, as consciousness fades into dream or dreamless sleep, let Einstein's story be a comfort. In a chaotic universe that often seems random and meaningless, there is order. There are patterns. There are laws that hold everywhere and always, mathematical truths that existed before humans discovered them and will continue after we are gone. This order is beautiful. Understanding it is joyful. Sharing that understanding is one of the most generous things humans can do for each other. Einstein shared his understanding freely. He could have been secretive, hoarding his insights, but instead he published them, explained them, defended them against critics, revised them when evidence demanded it, and helped others understand what he had discovered. He was, in this sense, a teacher not just in his formal academic positions but in his entire way of being. He showed us how to think about physics, how to approach problems, how to trust mathematics while remaining grounded in physical reality. And he showed us something about being human. You can be brilliant without being arrogant. You can achieve great things without losing your sense of humor. You can be famous without losing your humility. You can be disappointed by how humans treat each other without losing hope that we can do better. You can face death calmly, without fear, having lived fully and worked hard and loved as best you could, leaving the world different than you found it. These are not small lessons. In a world that often rewards ego and spectacle, Einstein's life reminds us that substance matters, that real achievement speaks for itself, that the best way to be remembered is not through self-promotion but through doing work that matters, work that lasts, work that changes how people see and understand the world. The house on Mercer Street in Princeton still stands. People sometimes walk past it, paying quiet respects to the memory of the men who lived there. Inside, he sat at his desk and filled notebooks with equations. He played his violin. He received visitors and discussed ideas. He wrote letters. He thought about unified field theory, about quantum mechanics, about the nature of time. And eventually, one day, he took his last breath and was gone. But the universe he helped us understand remains. The equations still work. The predictions still hold. Light still bends around massive objects. Time still runs slower in gravitational fields. Mass and energy still convert into each other according to that famous equation. The universe continues to expand, carrying galaxies away from each other, driven by dark energy we do not yet understand but whose effects we can measure. And humans continue to study all of this, building on what Einstein discovered, pushing further into the unknown. Physicists are probing quantum gravity, trying to understand what happens at the smallest scales of space and time. Astronomers are detecting gravitational waves from colliding black holes and neutron stars, observing the universe in a completely new way that Einstein made possible by predicting these waves a century ago. Cosmologists are mapping the distribution of dark matter and dark energy, tracing the evolution of the universe from its beginning to its likely far future. All of this stems, in part, from Einstein's work. Not entirely. Science is collaborative, cumulative, built by many hands. But his contributions were foundational. Without Einstein, physics would have taken a different path, would have reached its current understanding years or decades later, if at all. He mattered. What he did mattered. The hours he spent thinking, calculating, imagining, doubting, persisting, all of it mattered. And so, as we reach the end of this long night's journey through his life, perhaps the final lesson is simply this: your work matters too. You may not revolutionize physics. You may not become famous. But whatever you do with focus and care and honesty, whatever you contribute to the world's understanding or beauty or justice, it matters. It adds to the sum total of human achievement. It makes the world different than it would have been without you. Einstein would be the first to tell you this. Despite his extraordinary achievements, he saw himself as part of a larger community, contributing his piece to a puzzle that many hands were assembling. He stood on the shoulders of giants, as Newton said, and he knew it. Maxwell's equations guided him toward special relativity. Riemann's geometry gave him the tools for general relativity. The experimental work of countless physicists provided the data that theories needed to explain. Science is a conversation across time and space, a collective human effort to understand reality. Einstein was a particularly eloquent voice in that conversation, but he was not the only voice. We all participate when we think carefully about the world, when we test our ideas against evidence, when we follow arguments wherever they lead, when we remain open to changing our minds when facts demand it. These habits of thought, empiricism, rationality, openness, humility, are Einstein's legacy as much as his specific theories. He showed us not just what to think but how to think, not just conclusions but methods. And these methods work. They produce knowledge that is reliable, cumulative, applicable. The proof is all around you: the electric lights, the electronics, the medical technologies, the communications networks, all of it built on scientific understanding developed through these methods. So rest easy, knowing that the universe makes sense, that it can be understood, that brilliant people have devoted their lives to understanding it and have succeeded beyond what anyone could have reasonably expected. Rest easy knowing that Einstein walked this path before you, mapping territories that had never been explored, and that his maps remain accurate, still guiding travelers through strange landscapes of curved spacetime and relative motion and mass-energy equivalence. Rest easy knowing that curiosity is good, that asking questions is valuable, that wondering about the nature of reality is one of the most human things we can do. Rest easy knowing that every person who has ever looked at the stars and wondered, every person who has ever asked why things fall or how light travels or what time really is part of the same ancient quest that Einstein gave his life to. The night is deep now. The story is told. Albert Einstein was born, lived, thought, discovered, struggled, achieved, suffered, persisted, and died, leaving behind a transformed understanding of space and time and matter and energy, leaving behind an example of human intellect at its finest, leaving behind equations that will outlast nations and languages and civilizations, because they describe not human constructs but reality itself. Sleep now, gentle listener, and if you dream of light bending around the sun, of time slowing near black holes, of the universe beginning in fire and ending in ice, of particles and waves and the mysterious quantum realm, of gravity as geometry and energy as mass and all the beautiful strangeness that Einstein revealed to us. Dream of a curious child with a compass, a rebellious teenager hiking through Italy, a patient clerk in a patent office, a professor playing violin, a famous scientist advocating for peace, an old man still searching for the final theory. Dream of Albert Einstein, who showed us that the universe is stranger and more wonderful than we knew, that human minds can grasp these wonders if they try hard enough, that one life dedicated to truth can illuminate reality for everyone who comes after. Dream, and rest, and know that when you wake, the sun will rise because fusion converts mass to energy in its core, just as Einstein said it would. The day will pass because Earth rotates in curved spacetime, following the geodesics that gravity defines. And you will move through space and time, your personal clock ticking away your moments, each one precious, each one part of the vast interconnected universe that Einstein helped us see more clearly. Thank you for joining me on this journey through history, through one life that touched so many others, through ideas that reshaped reality itself. May you carry forward something of Einstein's spirit. His curiosity, his persistence, his wonder, his belief that understanding is possible and worthwhile. May you look at the world with fresh eyes, questioning assumptions, seeking patterns, marveling at the intricate clockwork beneath apparent chaos. And may you rest now in peace, cradled by the knowledge that we live in a comprehensible universe, that humans have made extraordinary progress in understanding it, and that the journey continues, that there are still mysteries to solve, frontiers to explore, questions to answer. The story of science does not end with Einstein. It continues in every laboratory and observatory, in every classroom and study, in every curious mind that asks how or why and refuses to accept because as sufficient explanation. Sleep well, kind listener. Let Einstein's story drift with you into the realm of dreams, where perhaps you will encounter him, smiling that gentle smile, eyes twinkling with some private amusement, hair fantastically disheveled, ready to explain once more that space and time are not what they seem, that reality is far stranger and more beautiful than common sense suggests, that the universe rewards those who look closely, think carefully, and never stop asking questions. May your night be peaceful. May your dreams be illuminating. May you wake refreshed and ready to engage with this mysterious, wonderful universe we all share. And may you remember, when challenges arise and answers seem distant, that Einstein too struggled, doubted, failed, and persisted, and that persistence, coupled with curiosity and courage, can carry us to places we never imagined possible. The stars that Einstein studied still shine in the darkness above you. The laws he discovered still govern their burning. And somewhere in the great unfolding of cosmic time, A moment occurred when a particular arrangement of matter became conscious enough to ask what it was made of, where it came from, and where it was going. Einstein was one answer the universe gave to its own question, a mind capable of comprehending minds, a pattern capable of recognizing patterns, stardust awakened to wonder at stars. You are another such answer. We all are. And together, across generations and centuries, we build understanding, piece by careful piece, question by patient question, discovery by hard-won discovery. Einstein gave us his pieces. They were magnificent pieces, and we remain grateful. Now it is our turn to wonder, to question, to seek, to understand as best we can, and to pass forward what we learn to those who come after. Good night, kind listener. Rest now. Dream peacefully. The universe is vast and ancient and strange, but it is also, Einstein showed us, understandable. What more could we ask? Sleep well in this knowledge, this comfort, this invitation to wonder that Einstein extended to all of us simply by living his life and sharing what he discovered. The story is complete. The night is yours. May it bring you rest and peace, and may you wake to face tomorrow with something of Einstein's spirit, curious, questioning, humble before the mystery, confident that understanding is possible, ready to think carefully about whatever problems the day presents. This is the legacy he left us, and it is a good one. Sleep now, and carry it with you into dreams, into morning, into all the days ahead. Good night.